So good afternoon all, and thank you for giving opportunity to present the paper in international conference MICRT STM. So also I thank you Ajinkya DY Patil School of Engineering, Loga. So today we are presenting our paper Pneumonia Detection and Classification using CNN and deep learning using VG16 module. So basically these paper which are listed in our schedule in two times, the paper ID 64 and 66. I think there is some mistake, but we are presenting this paper in a one title. So I request to organizer please consider this 64 and 66 is a both same paper. So thank you once again all of you. I will start my session. So pneumonia detection and classification using CNN and deep learning. So why this need? We have a find out this paper and this title. So we will go through the outline regarding the our statement, what we have planned. So whatever purpose, objective, literature survey we have done, the scope, requirement, system overview, our all diagrams and implementation techniques and performance analysis. So that is our outline of our paper. So problem statement, when you think about the pneumonia detection, so in the pandemic situation, there is a problem, the both COVID-19 and pneumonia. So both giving the same symptoms. So there is a challenge to analyze the who will go affected with the COVID and who will affected with the pneumonia. So for that purpose, we have planned this uh, analysis and we have generated this the problem statement and we are working on that. So to design and implement pneumonia detection and classification using CNN and deep learning using VG16 module. So next, purpose. So I already discussed that purpose pneumonia. So there are when consider about the pneumonia, there is a two stage like bacterial and viral. So in bacterial, there is people which are overlooked to early stages. So there are some stages we can detect the how the bacterial infect our system, our human uh, health, that all we can consider with the bacterial diseases. There are another purpose to timely detection. These diseases can help to fast track the process of recovery. So after that, when you see the death ratio of previous of pandemic situation, so pneumonia also effect on the death ratio. There is a uh, very less point, but it is affecting to death ratio. So pneumonia, it is also one of the important diseases. We have to focus on that. So for that purpose, we have selected this topic for analysis. Next, extraction of chest X-rays to identify early symptoms of pneumonia. So how we can find out the pneumonia detection on the basis of X-rays and all the symptoms. So that we can consider about your viral and bacterial. Now we will discuss about the objective. Objective we can say either to learn different biomedical terms related to pneumonia diseases. So there are when we all are engineers, but we know, so we have to know the some technical terms related to diseases and medical terms also. So for that purpose, here we can in this topic we will learn the some biomedical terms also to learn the different scenario for pneumonia diseases. So now there are the two basic scenarios. The one is the viral and another one is the bacterial. So how bacterial, which will be effect, and how we can detect the pneumonia is a bacterial and viral. So that is the one algorithm to analyze this viral and bacterial. Next objective to learn different methods for data acquisition. When you collect the data and analyze the data, so there are various different algorithms. So that algorithm, like we can say the CNN and some deep learning algorithm. So that in this way we can find out the data acquisition. And last, to know about the different images processing pre-trained model. So when you reaching to find out the pneumonia detection and reach to the final assumption this is pneumonia, so we have to find out the various images. On the basis of that images, we can analyze our algorithm and we will get some trained data. So on the basis of that data, we can finalize that symptoms which are related to pneumonia and other diseases. So next is the to use VGG16 for feature extraction. So when you find out the various images and data, so the first stage is the feature extraction. By using this VGG16 algorithm, we can extract the feature on the concern of various dimensions. Next is the to develop model detect phenomena. So CNN algorithm and VGG16. So both we are using and we are developing one model to detect the pneumonia, which is easily to understand the doctors and which will help to assess that diseases also. Now to learn the process and transfer the learning, so that is also one important aspect for the our pneumonia detections. So last is to build web application, analyze the pneumonia diseases by using chest X-ray. So many of people are going to the various laboratories to decide, so take the X-rays and some other laboratory checkups also. So there is a one term that is X-ray. So on the basis of X-ray, we can find out the how many percentage which is affected on your lungs and other things. So which will be know about the test by the chest X-ray. So again, that we can take a input for our model, and after that VG16, which are make the feature extraction, and then we will find out the symptoms, how many affected and all that thing. So now I request my colleague Kritika will continue about the next slide, literature survey. Thank you.
Thank you, sir. Hello, everyone. I am Kritika Patel. I am going to tell about the literature survey. We have collected 4 literature reference paper for this project. First reference title is Transfer Learning from Pneumonia to COVID-19. In 2020, COVID-19 was at peak. So that time this paper was published, and in this paper we studied about the transfer learning method, which is usually a process where a model is trained on one problem and which is used in some other detect pneumonia, and by using pneumonia detection we can detect COVID-19 also. This method is in deep learning. This is a technique where a neural network model is first trained on a problem similar to the problem that is being solved. In this 80% in this problem, 80% accuracy are there and 86% for transferred COVID-19 models accuracy are there. Now we go to the second reference title, which is Pneumonia and COVID-19 Detection Using Convolutional Neural Network. This paper is also published in 2020. In this, we used Kaggle, where we we download the data set from Kaggle, and model in the components is there: convolutional layer, batch normalization, pooling layer, activation, deep learning, models of convolutional neural network. This was also paper. CNN architecture is used to detection of pneumonia diseases. In this, processing models are there. We used deep learning based detection and segmentation of COVID-19 and pneumonia on chest X-ray image. In this paper, 3 types of X-ray images are classified. During prediction, each image is passed through the classification process, classification layer, and then it is classified whether it is COVID-19 or pneumonia, and then we can get the proper disease. This is the methodology. Now I go to the scope of this. This is the scope. In this module 1, we are going to, this is image acquisition. We are going to use X-ray dataset to diagnose pneumonia. In this, images are taken from the external source, or we downloaded the dataset from the Kaggle, and then second module is pre-processing. In this, to balance the training database, we use batch normalization or maximum normalization. In this, image will be resized in 500 into 500 format. Otherwise, while using this, limiting the memory load is also is imposed by the convolutional neural network training. Model 3 is development. We are going to train and test the data set which we have downloaded from the Kaggle, and we have going to develop the project with the help of Colab or Jupyter Notebook. And the model 4 is classification, in which we classify the image of viral and bacterial pneumonia with the help of filtering pooling process of VCG16 model. And in this system, we will going to classify the image according to the heat maps. Now the requirements for doing this process, we have a hardware of Intel Core i5, NVIDIA GTX 1650, and a 8 GB RAM. And the software needed for this is Google Colab, Jupyter Notebook, and Kaggle datasets. Now I request one of my colleagues, Dr. Prayshee Bhattacharya, to execute the next part.
For giving the opportunity. So first is basically as Sir told and Kritika told about the objectives and the reference papers. So system overview, in that we can see the 4 processes which will be taking place in the project. First is the image acquisition. So from that we have to first collect the image or whatever photograph X-ray image is there from the data set, and then we have to pre-process. Pre-process it means we have to feature extract the data, and then there will be the development, and further the classification will be done using the CNN model. Then after that is the activity diagram. In that we can see the process, like we can see the start, then is the read data set. So first the data set is collected from the Kaggle one, then the processing is been done by the pooling layer and the convolutional layer. And then first it will categorize that whether that image is clear or not. If it has not been clear, then it is cropped and resized images are done further. And then the data set is being split as COVID or pneumonia. Then the data model has been fit in that particular data set, and then the features are being extracted and predicted, and the accuracy is being checked, that is around 90% or above. And finally, once it is been collected, it's been done. So that was the process. And then is the algorithm and technique. So first we are using the libraries of Keras and TensorFlow. So it's an open source neural network library which is written in Python. Basically, we use it for making models, defining the layers, and for multiple input and output models, where one input and one output will be generated in this. Then is the TensorFlow. It's an open source artificial intelligence library. In that, the graph models are being showed. And here we are used basically for the classification thing. Then is the perception, then is the understanding, discovering, prediction, and creation. So these are the processes that are playing the fundamental roles in our project. Then is the feature extraction. So basically, it is a visual information that has been collected from the image. Basically, the X-ray image, that how much the data has been accumulated, or because digital mammographic images are specific, all features need to be collected for further analysis. And then the suspected tissues, it may be of different shape and composition, and based on that, the GLDM, that is the gray level difference method, or the local binary patterns, are used for extracting the features from the X-ray image. So these are some of the popular extraction techniques which have been there, like GLDM, GLCM, and Gabor texture feature. So GLDM is a gray level difference method, where basically the X-ray is not colorful. Basically, it may be in gray color or in bluish shade. So basically, the texture should be properly identified. So we are using this technique in that. There is a co-occurrence matrix, which is showing the tabulation form of different pixel brightness values, because each and every pixel has been considered while during the analysis, so that the proper prediction has been done. So there is a Gabor texture feature, which is a linear filter, which is used for the age detection, and the grayscale character images, which are specially designed for the statistical information. Next is what is Kaggle basically. So we are considering a data set from the Kaggle, which will be comprising of 20,000 X-ray images, and we will be utilizing that for further analysis. So there will be a web-based data science environment, which are used by several data scientists and machine learning engineers for data analytics. Then our data is, in 2017, Dr. Paul Mooney started a competition on Kaggle on viral and bacterial pneumonia classification. So it consisted of 5,863 pediatric images, which is different from the other data set. So we are using the revised version of that particular data set. So basically, this is a CNN architecture which we are using in our project. So X-ray image, there are two layers, which is a convolutional layer and the pooling layer. So convolutional layer is basically for the feature extraction, and pooling layer, fully connected layers, is for the further processing. So next is the data set pre-processing. So as we know, the concept of data augmentation is basically used for the changes, for reshaping, for resizing the particular image to fix it into the particular web application. So for that, the first is the rescaling one, which is for changing the pixel range. Then is a shear range. Like we know that the shearing range is from 1 or to 0. So we can zoom out and zoom in the picture. Then is a horizontal flip, which are flipped horizontally at random. Then the vertical flip, which we can flip vertically. Rotation range is there. We can entirely rotate the complete picture from 0 to 180 degree. Then is we can shift the image horizontally and shift the image vertically. Brightness range is also there, so we can correspond to the maximum brightness so that the picture can be properly analyzed. So convolutional layers, so these are some of the functions what they perform. Like the convolutional layers, they are particularly the neural network. It is acting as a feature extractor, and from the feature map, we can analyze the further image. So pool layers, the second block is not a characteristic of CNN basically. It is used for classification purpose. Each element is there between 0 and 1, and the sum of all it is worth 1. So for that, in this layer, basically the sigmoid function is used for the binary classification is 0 and 1. Then is the rectified linear unit function as an activation function. The activation function decides whether the neuron should be activated or not. And the sigmoid function is basically the logistic function which can give us the correct prediction of the output. Then is the VGG16 model sequence. You can see where the different layers are being utilized for the further process in this. And here is the convolutional layer and the pooling layer. You can see the working of it, that how they are getting switched and how each and every pixel of the image is been analyzed. So that is the pool feature and the convolve feature. And from the convolutional layer, it is been transferred to the pooling layer for the further analysis. So this is basically the internal structure, the internal analysis of the image which has been done before the prediction. Next is the mathematical model, which is the confusion matrix, which we have used for generating the true positive, false negative, and true negative data, which is being presented in an X-ray image. So here we can see that how many X-ray images are actually pneumonia based, which are actually COVID based. We can predict the normal lungs and the attack lungs by the pneumonia. So this is the classification report. We know the precision, we call an F1. These are the three fundamentals of the confusion matrix which are being utilized. So for so that we can definitely efficiently able to classify the COVID and the pneumonia. So this is some of the CN model sequence algorithm which is being implemented in a project. So FIT model, early stopping is being used for which FIT model is basically considered for the confusion matrix because overfitting and underfitting are some of the situations that have been faced in the data analysis of the X-ray image. Then here is the early stopping, 9th epoch, which has been shown. Here is the performance analysis. So we can see that eventual test results, it varies from 95.98% accuracy. So these are some of the references, and so I end my presentation here. Thank you.
Thank you, ma'am. Thank you.